Happy Wednesday, everyone. Our webinar today is being held at arguably the best time of the year. Why is that? Because it's World Water Week. So of course we're here to talk about water. That's right, we're going to explore the current state of water conservation and efficiency by looking at the most popular products that help to conserve the water we use, and mention national residential water conservation programs that provide a roadmap for building sustainable water-efficient homes. Back with us is Darren Waschek, who is the president of Learning Edge LLC, a firm that specializes in residential energy efficiency training and building science consulting. Darren was a key implementer of the EPA's Energy Star for Homes program for more than 20 years. He has helped solve warranty issues for hundreds of homes and trained thousands of individuals on the basics of building science, energy efficiency for buildings, energy efficiency programs, and also the International Energy Conservation Code. He holds a bachelor's degree in construction and a master's and doctoral degrees in public administration and policy from Arizona State University. Now, we have a wonderful partner with us today, and that is a partner in NV Energy. And they want you to know about their incredible tool called PowerShift. It helps residential and business customers conserve energy and save money on their power bills. PowerShift is a one-stop resource to find energy-efficient products and services. For more information, check it out at nvenergy.com/PowerShift. Now, during the course of today's presentation, you can submit questions for Darren. Simply use the Q&A box located at the bottom of the Zoom window. I'm going to look over those questions and pose those to Darren after his presentation. Darren, you know this is a subject that is near and dear to me. I am ready to dig in.
Yes, I know, Mike, and I appreciate you bringing up the water month. It caught my attention as well that's exactly the timing. So well said in putting that together. And Mike, I do know that this is near and dear to your heart. So thank you very much for having me in today. Very excited to be back with Green Builder Media to share another class of information. So today's High Performance Home Master class is Water Efficiency in the Water Energy Nexus. This is the only class that I get to teach, and I like to put it that way, on water efficiency. The rest of my classes focus on energy, but we're not going to leave it just at water efficiency today. We're going to talk about that nexus between water and energy and try and make that as clear as possible for everybody. So thank you, everybody, for being here today. What we're going to cover is, to begin with, background in history, just a little bit of background on our topic. And a little history, in fact, that goes along with that. So I want to share that to kick us off and kind of lay the context and the foundation. Then we're going to dive in and look at what do we mean by water energy nexus? What does that mean? And how does that apply? So we will look at that in our next portion of the presentation. Then we're going to look at water efficiency programs. There's not a lot out there, but we'll look at the biggest and most popular ones, or at least elements where that falls in. We'll talk about some products. I'm not going to cover every product that is available out there. I'm just going to talk about the most common products that are available. And then at the very end, I'm actually going to talk about some other products I've tacked it on there, but rainwater, gray water, and some other stuff. We only have about 60 minutes together, and my goal is to try and keep my content to about 60 minutes. So it's going to be covering a lot of content and an overview of a lot of things, but I'm looking forward to sharing that all with everybody, all of that with all of you today. So let's get started. Not quite started. I did want to make you aware that, because this question will come up inevitably, will the slides be available after class today? Yes. If you complete my feedback survey at the end. So when we get to the end, you guys will get a URL. Mary will drop it into the chat, a URL, and also there'll be a QR code. So when we get to the end, get your phones ready. You can hit a QR code, do a quick feedback survey for me, and I will then, when you're done with that, it's only 3 questions. It's very simple. You'll get a link to download the presentation slides right away after class. So keep an eye out for that, but kick back and know you're going to get all the slides. So how precious is Earth's water? So if you look at all the world's water and you were to scrape it all up and you were put it into one ball, basically you'd be looking at a ball 806 miles in diameter. And if you compare that To the Earth's diameter, it's about a tenth, right? Almost 8,000 miles for the Earth. So that's it. That's all of the water. We've got a big planet, but there's this thin layer that wraps the building that makes us blue because of our oceans, of course. And 0.105 of the Earth's volume is what that equates to. So it covers, though, 71% of the Earth's surface. 96.5% of the water is in our oceans. 1% is undrinkable, that's in the atmosphere, swamps, salty lakes, salty underground aquifers, and biological, meaning it's in all living things, plants and animals. Now let's just look at the stuff that we actually can drink, the freshwater stuff. 1.74% is in the ice caps, glaciers, and permanent snow. Okay, so it's accessible to us, but not readily. 0.77% is drinkable water in the places where we normally get it from, lakes, rivers, streams, groundwater, underground. So that means that 0.77% of all the water that's available to us supports every plant, animal, and insect that's not in the ocean. And so, yes, I think this illustration makes it very clear how precious that we're all basically fighting for that 0.77% of what our water is out there. And of course, there are ways to turn some of this other water, or unlock some of this other water so it's drinkable, fresh water, desalination, those types of things. But when we look at the natural occurring water, this is what we're dealing with. Now, when we consider drought, what we expect is this. So this is basically a picture that shows what the drought conditions are in a typical year or a 12-month period in 2020 to 21, February to February. And you can see that the biggest degradation areas, the dark browns and whatnot, are going to be planted pretty much in the southwest part of the country. This is what we typically expect. This is why, quite frankly, we have in Lake Mead, but right up there on the border with Nevada and Arizona. We've got the bathtub ring out there on Lake Mead because that water source keeps going down and down and down as it continues to try and keep us or supplement the drought conditions. So yeah, this is what we expect. And it's because we live in, look at the ICC map, the dry part of the country, the western part of the country, getting the designation of B. What we don't expect, though, is this. So this was in a one-year period, 2006 to 2007, in the southeastern part of the country, more specifically Atlanta. And this was an article in the New York Times about Atlanta shudders at the prospect of empty faucets. This isn't anything that we would expect. The lake that provides drinking water to almost 5 million people in Atlanta has been draining away in a withering drought, the worst drought on record in the Southeast. In late September, when Lake Lanier forecast to dip into the dredges of dead zone, less than 4 months, the state imposed a ban on outdoor water use. So I will tell you that in Phoenix, where I am, we've never had a ban on outdoor water use. They've done it in California. They've done it other parts around in other places. At least they're considering it there. But again, this is a condition that's just not unique to the southwest part of the country. This can happen anywhere under drought circumstances, and that's what I want to share. If we look at, from the EPA's WaterSense program, some statistics, domestic water use in gallons per day per person and percentage of population growth, really a great map here. So if we look at just the colors, the domestic water use, darker color means using more water. And then the percentages are the population growth. So the disconnect here is that you can see that some of the largest population growth locations in the Southwest are where we have some of the biggest water consumption being going on. And so this is that disconnect that's going on. And again, that's partly because we just don't have much precipitation. And so we're going to be watering lawns and using water more intensely. And so this is just our reality. Now, this is a bit of a good news situation. When we looked at daily indoor per capita water use, and we consider where we were in 1999 at 69.3 gallons per capita per day. Well, by 2016, that had dropped to 58.6, which is basically saying that we've done better with our water conservation. We've reduced it by 15% over the course of basically 17 years. And so we're heading in the right directions. Good things are happening when we look at this. When we get to the end and we look at products, I'm going to share some information about part of how we were able to accomplish this and what we were able to do to make this happen. But we'll come back to that in a little bit later in the presentation. So getting fresh water, that 0.77% is an ancient problem. Going back to ancient times, the city of Rome basically was supplied by fresh water with lots of aqueducts. And so they had a total of 11, anywhere from 7 to 56 miles away. They were bringing fresh water into the city of Rome in order for the city to grow. So in order to have any metropolitan area or city of size, you've got to have fresh water. And so that's how the Romans solved it. And anywhere else that they had a large city, they had aqueducts. And importantly, it was continuous flow. Okay, so that was continuous flow. That water flowed in. Now, the truth is they did have some holding tanks when it made it to the city. There were very large holding tanks that they would then release the water from to give it a little bit of a control. Pretty much, though, it ran right on through to the Tiber River is what was going on for the city of Rome. And the distribution was in plumbing of the day, terracotta pipes. You'll notice in the terracotta pipes that they had the buildup there, right? And that was the hard water deposits that were lining the inside of the pipes. Eventually, over 100 years or so, that would restrict the pipe so much they'd have to replace it. But again, terracotta and clay pipes is how they plumbed. Now, when we talk about continuous flow, the water would flow first as a place where they would get the water for drinking out of a fountain in maybe the central square of a neighborhood. Water would flow then to other uses, like ultimately the baths. And so they would then use the water that was flowing from the faucets to the baths, warm that water and use that. Then it would flow from there into, and the baths usually had the toilets. And so here's an ancient Roman toilet. And that water is continuously flowing and carrying everything on out to the Tiber River. And then this was an interesting little innovation, right? They had the little basin down in front that would allow continuous flow with the water trickling, and you could wash your hands. That was your sink right there in front. So this is how they did it. This is how things were done. Now, they also had smaller pipes, and the pipes were made from lead, and most people from history understand that. And what's interesting about the lead pipes is how that actually carries all the way to today. So lead in Latinum is plumbum. The symbol for lead on the periodic table of elements is Pb, okay, symbol for lead. Those who work with water pipes in Latin are the plumbarius. And then, of course, in English, we call them plumbers. So the lead pipes from ancient times comes all the way down to the piping and the plumbing that we have today, and that name carries all the way forward. Typical dimensions of the lead pipes, very fascinating how they make them, by the way, but usually about 10 feet long, 1 inch to 2 foot in diameter, very large size. I was surprised that they were quite that large. And then I have to throw this in because everybody thinks about this. Lead poisoning, I did a little bit of research on this, and they talked about that being the decline of the Roman Empire. Well, in reality, when you looked at that, there were two factors that were working in favor of those drinking that water. One is that it was continuous flow. So the water wasn't able to sit there and pick up the lead from the pipes because it really wasn't sitting in those pipes. Again, this is just some of the stuff that I was able to find. Although if the lead pipe was in a house and somebody hadn't turned the spigot on yet, I guess it was sitting there. But also the calcium carbonate buildup that we looked at. That was also lining the inside of pipes, all that hard water, which means that there was some level of protection from that water. Again, jury's probably still out. I just wanted to share some of what I found when it came to the lead poisoning issue, because it's obviously real. And whether it was a real problem or not, hard to say. Now, let's dive into the water energy nexus. Okay, it takes water to produce energy, and it takes energy to move and to treat water, to move and treat water. So water to produce energy. We look at some of the data that I was able to find out there. 10% of global water withdraws, okay, is basically devoted to power generation, as you can see in the chart here, 10%. And if you look at that 10% and break it down into the power sectors, the energy sectors, you can see that nuclear is using about 28%. The fossil fuel is 58%. And so when we look at this distribution, I want to dive for a second and look at nuclear, because in Arizona, actually just west of Phoenix, in Tonopah, we have the Palo Verde Nuclear Generation Station. And this is actually a really good news story, because there's a lot of water that's used for nuclear power, as you just saw. And one of the largest power plants in the US by net generation is Palo Verde. It uses 26 billion gallons of water annually for cooling the nuclear reactors. But I've underlined the important piece: reclaimed water. And so to put a huge water consumer in the middle of the desert and needing water in order for it to operate is definitely another disconnect. But we've done a lot of good things in Phoenix and in Arizona to deal with the fact that we get that we're in a desert. And so when they were building Palo Verde, they went out to the municipalities, and in specifically Phoenix, Mesa, Tempe, all from the Phoenix metro area. And they said, we want you, and we in fact will buy from you your wastewater stream. So they built the infrastructure for these municipalities to send it out to a wastewater treatment facility on the west side of the Phoenix area. And they basically treat that water, and then they send it on to Palo Verde for the cooling process. So this is reclaimed water, not the fresh water that we would otherwise drink. Great use, but it's dealing with that reality that the nuclear power facilities use a lot of water. Okay, so water to produce energy, typically we're talking about a thermoelectric power plant. These are the items that are going to generate the power, right? The power plants that are out there generating that. Now, the fuel is what's variable when we're ultimately trying to create steam. So we can create steam with coal, natural gas, nuclear, solar thermal. This is where we're actually warming up like a molten salt compound with the sun. We're taking that hot molten liquid, putting it into a storage tank, and then after, when the sun goes down, then we're using that to create steam. And then, of course, geothermal, we're pulling that hot water or sending the water down into the earth, warming it and bringing it back so that we can spin a turbine. That's really what we're trying to do there, is make steam. Now, we can also turn that turbine without steam by hydro, right? The dams, the pressure at the bottom of a dam wants to blow that bottom of that dam out. Well, that's going to spin a turbine as well, and it does. And so that's one way. Or wind will also spin a generator so that it will ultimately create energy. And then, of course, the other way is to just go directly to electric production, and that's going to be our solar, right? But when we're looking at the thermo plant, what we're really doing is cooling the water in the cool tower. So that's steam coming off. And so we have water loss there, but we also have water that's falling through into the basin. We're going to have to supplement that if we lose some. So we're adding water in there as part of our process for generating electricity. So water's throughout this process. And in fact, for the hydro, again, we're directly spinning using water, the energy of water, to generate electricity that way. So energy to extract, distribute, and treat water. So this is now using the energy on the other side of the nexus in order to, again, play all these roles. So energy is needed in each step of the way. For supply and transfer, treating water in order to make it drinkable, the distribution system. Back in the day, it was always gravity feed, right? So in the ancient times, the water was delivered, but you had to be downhill for that water. They did have some pump technology. If you really dig into what was available, they did have some pump technology, but we are moving water all the time with pumps. And so we're using energy to do that. And then again, wastewater collection, treatment, discharge, so on and so forth. So we're using power all throughout this process. 4% of global electricity consumption, in fact, is used for extraction, distribution, treating water and wastewater. And interestingly, 50 million tons of equivalent oil equivalent is used for running generators. There's a lot of pumping going on, and that's usually in places where electricity is not available. They're going to be using generators to pump that water. Now, transfer, getting water from its source to where it's needed, of course, is critical. This is what the Romans were doing, is bringing it from its source to where it was needed. And so transfer is a big deal. I want to give you an example of a big energy consumer moving water as part of the Central Arizona project. This is basically a huge water project, 336-mile a canal basically that brings the Colorado River into the central part of Arizona, where I am in Phoenix, on down to Tucson. And so this was basically feeding and supplying and making our existence in the desert possible, 80% of our population being serviced by this. So it was started in 1973. It took 20 years to build, $4.4 billion. That was the loan from the federal government. A portion of that's being repaid by fees collected from the water users of the Central Arizona project. So 4.4 billion today, that's like a bargain, I'm sure, in today's dollars. Now, importantly, water is lifted. So that water is lifted a total of 3,000 feet because it's lifted and then it's allowed to go down, flow downhill. Then it needs to be lifted again. But its pathway needs to overcome that terrain to get it to the Phoenix area and then on down to Tucson. There's 4 tunnels that I think are fascinating, where it's easier to go through a mountain than over it. They'll tunnel, so they don't have to lift the water over that. It's just cheaper to do it that way. But this is the big energy consumer. The largest energy user in the state of Arizona is the Central Arizona project, 2.8 gigawatts hours annually of energy consumption. 80% of the total energy is consumed right at the beginning. 66,000 horsepower pumps. They lift that water 824 feet for it to start its journey into the Phoenix metro area. So it's up over the Buckskin Mountains that you can see right in front of you. That's got to lift it up there and then start its journey down. So that's where a huge chunk of that energy is consumed. In fact, so much energy was needed for the Central Arizona project all along that they built a generation station, Navajo Station, just for that purpose. And it burns coal, and the CAP used 24% of that output for that plant. It provided 50 to 60% of the energy for the CAP. It was decommissioned in 2020, and they supplemented that with other more renewable sources of energy. But if you consider, again, the nexus between water and power, this is a crowning example of where they work together. Now, I want to also bring it, those are big things. Let's kind of bring it closer to home and talk about the water energy nexus right in your kitchen, in your laundry room. So a lot of people wonder why the water programs require Energy Star appliances. And there's a really good reason for that. And that is that dishwashers that are using water, they save energy. They become more energy efficient because they use less water. And it takes a lot to move water. In fact, let's go to the clothes washer example, because I think it's even an easier one for us to understand. When you have a top-loading clothes washer, we throw our clothes in and then we fill that container up. And then a motor needs to shake that and agitate that water as well as the clothes inside. And if you were to do that by hand, you'd get tired really fast. So it takes a big motor and a lot of energy to move that water. However, if we were to take that clothes washer and we were to do it front loading, and we were to put the clothes in and rotate the clothes through a small amount of water sitting on the bottom of the drum, well, now we could use a lot less water. And in fact, we would need a lot smaller motor to move that clothing through the water. So we're moving less water, and it's going to use a lot less energy. And so that's where that water energy plays in with our appliances, and why Energy Star, when they're looking for water savings, they say, do an Energy Star dishwasher, do an Energy Star clothes washer, because you're saving water and you're saving energy. So that's another great example of that nexus in the appliances that we use. What about water heating? Okay, the nexus of water heating in homes. So we have water loss because we turn the faucet on and in our bathroom, and then we have to sit there and wait for the water to flush out of the pipes, for the hot water to come in behind. And then finally, once we've flushed out all that cold water down the drain, total loss, then we have our hot water. Okay, so that's a water loss. But then we also have an energy loss, because the water that we bring out of the water heater eventually will stop asking for hot water, and it will sit in the pipes and it will cool down. So that's an energy loss when we talk about that. But if we were able to reduce the water loss by running our water out the faucet, and we were to then reduce that, we would also save on our energy as well. And so we could save on both. This is some research that ResNet did when they were preparing their HERS H2O, or their water energy rating index. They did a bunch of research in order to build the models for this. And I'll show you the water calculator for HERS H2O here in just a little bit. But they ran all the numbers, and they, for example, water recirculation systems, if you add an R3 pipe insulation on there, you're going to see significant savings in water savings, 14 to 15%. And then in energy, anywhere from 15 to 18% or 15 to 19% of energy savings. So again, a demonstration that if you save water, or you do something to save water, you're ultimately going to be saving energy as well. So it's a great example of that. All right, I want to jump now into the water programs. Let's look at, of course, the most popular, the biggest one out there is the EPA's WaterSense program. The program originally, 1.0, version 1.0, was prescriptive. So there was a list of things that you needed to do if you were going to be WaterSense, and there wasn't really any flexibility. You had to do certain things, and that was it. With 2.0, WaterSense basically, once there was a methodology for calculating kind of a performance standard, which HERS H2O did. They're not the only one, but HERS H2O was calculating it. It was one of them. But it became clear that a performance process would be a lot more flexible, and it might even get more builders to join the EPA's WaterSense program. So it's no longer prescriptive. You must demonstrate, as part of the WaterSense program, 30% more water efficient than your typical construction, okay? But there still is a mandatory checklist that's got a few things on it. I'll show that to you here in just a second. But there are a few things that are critically important that WaterSense wants, and so there is still a few items. Now, in order to establish this baseline, you can see the items that are looked at for indoor as well as outdoor. So it's not just indoor, this is indoor and outdoor together. And in order to establish the baseline, these are the items that that are looked at for establishing the baseline. Now, the 30% more water efficient is established by a WaterSense approved certification method. So we're here, the EPA, federal government, so we got lots of acronyms, and WACM, and that's basically the methodology that you would follow to calculate 30%, all right? Now, WACMs are developed by the home certification organizations. You guys are probably familiar with HCOs for the Energy Star for Homes program. They're also home certification organizations. Well, EPA borrowed from itself with the WaterSense and said HCOs are now going to be the water providers, or the water implementers. They're going to implement the program. So independent oversight, quality assurance, verifier training and authorization, home verification protocols are established, impartiality, messaging, and reporting. And so this is the role that the HCOs play. It's exactly like the home energy rating providers do that are part of the Energy Star for Homes program. Now, who are the HCOs? You can see them on the left there: Cheers, Green Builder Coalition, NGBS Green, and ResNet with their HERS H2O. And then their method for calculating the 30% savings is listed over on the right-hand side there, okay? So that's what's listed on the right side. Now, if we look at the mandatory checklist, this is the only things, this is the legacy items that were left over from 1.0 that they said, no, these are still going to be mandatories. You got to do all these things. And a big one clearly is leaks. Because if you think about it, water leaks, you get no benefit from that, okay? Before it ever is utilized for a shower, for cleaning, for washing, for drinking, for any of those purposes, that water never has that benefit because it's leaked out. So the number one thing we can do for conservation is to reduce the leaks, minimize those as much as possible. So we'll talk just a second about some of the things that we do and what they look at there. And then next, of course, they did want to stick with the WaterSense labeled products. So if you're doing WaterSense, your toilets, your bathroom sink faucet, not the kitchen faucet, your bathroom sink faucets and your shower heads, they must be WaterSense labeled. So here's that pared down mandatory checklist that's part of the WaterSense program. Now, if we look at water leaks, there's one of the things that we want to do is make sure that we don't have surface pressure above 60 PSI, pounds per square inch. And of course, if we have really high pressures on our pipes, then they're more likely to leak or burst. And so we want to keep that below, for the WaterSense program, 60 PSI, nothing more than that. But this little test that we do, hook up a little gauge to a water spigot, a hose bib outside. This little test for water pressure also allows us to determine if we have leaks in our plumbing system. So if you were to, in this case, put the gauge on there and it gives you a 50 PSI reading, first of all, that's a beautiful reading. But then if you were to walk away and come back 15 minutes later or so, and that's dropped down to 45 or 40, the bigger the drop, the more that tells you there's a leak somewhere, because leaks will then take that needle and they will reduce the pressure inside because you're relieving the pressure. So it won't tell us where the leaks are, but this little test will also tell us if we have leaks somewhere in our system. So it's kind of a twofer there that we get out of this test. We're also going to do things like dye tabbed in the toilet tanks. If the flapper is leaking, well, the water in the bowl will then turn blue, okay? Now, this is before you flush it, of course. You just drop it in there, come back in a couple of minutes, and if that water is turning blue before you flushed it, that means the flapper is leaking. So that's one way to do it. And then to the outside, we want to make sure that our irrigation system is not leaking. So certainly what we see here with those external valves leaking, that doesn't work. That's a major problem. And so WaterSense will make sure that gets done. And then lastly, of course, your toilets, your kitchen faucets, and your showers, they need to be WaterSense labeled. When you're all done, the WaterSense team that's doing the verification, which is typically the same guys and gals that are doing your home energy rating. They will typically be the ones that will also do your certifications. And it depends, again, where you are and who you choose to use, but you'll get a certificate from a WaterSense. I haven't seen a WaterSense label for anything, but they do have their certificate. Okay, I want to take time because I'm most familiar with looking at the ResNet HERS H2O. And I should clarify that the HERS H2O was actually developed in close partnership with EPA. Basically, the WaterSense program was very involved in the development of HERS H2O. And so there's a lot of similarities between the programs in terms of the assumptions that are made, the things that are looked at, which I think are probably pretty universal anyway, but they're pretty close. So there is a field data collection form. In fact, this might have been updated more recently, but this basically is the checklist that you follow for data collection in the field, that ultimately that information is put back into the HERS calculator, the H2O, to calculate your score. And there are no minimums or mandatories for the ResNet HERS H2O. So they don't require you to do WaterSense. and they don't require you to do anything specific. It's a pure performance method. And of course, if it's water sense, then you got to hit the 30% mark. The water use calculator has a reference home. That reference home is effectively the 2006 vintage water consumption home. And so when ResNet was developing this, they had to go figure out, well, what was the state of the art, if you will, in 2006? As many or most of you probably know, the ResNet HERS index is based on the 2006 IECC. And so that 2006 was the number. They said, might as well keep it the same. So they figured out that will be our baseline. Again, performance rather than prescriptive, and that does allow greater flexibility, not defining exactly what you do what you're going to do, but then you've got to hit a mark if your water sense of 30%, or the calculator certainly initially was and continues to be a spreadsheet. All the yellow boxes you fill out. Well, what's the gallons per minute for your shower head? What's your kitchen faucet, your lavatory faucets? And so you input that information in, and ultimately it kicks out your HERS H2O, okay, your score. And in this case, our score 98 is 2% better than your standard 2006 reference home. Now, big announcement that was made in the beginning of this year is that Ecotrope added in a water rating index calculator. So if it's a spreadsheet, it certainly can be turned into an app, right? So I was thinking that maybe there would be a standalone app for the HERS H2O calculation. But it makes a ton of sense that Ecotrope jumped in there, and they have now in their software the inputs that will calculate the HERS H2O. So that's great. Took a little while for that to ultimately happen, but glad to see that ultimately that did happen. This is the label that is part of the ResNet HERS H2O, and the water energy rating index, the WER index they call it, giving you your information for the HERS H2O. Now, let's look at the other program that's out there that has a significant water component, LEED, right? Leadership in Energy and Environmental Design. It's a scoring system that LEED has. And they look at not just energy, not just indoor air quality, material sites, but they also look at water. So you get a holistic look at in a true green when you're looking at a program like LEED. It's going to be comprehensive. So the categories where you grab your points from are listed here. What I want to do is just look at the one that we care about, the water one, okay? So what is LEED doing in the terms of trying to push water efficiency in the buildings that are LEED certified? So first of all, there's a prerequisite. You must have water metering. I imagine there are certainly places around the country where water runs into a house and there's no meter on it. So whatever water you use, that's fine. But there is a prerequisite, there be water metering. And I suppose if you have a well, you may or may not meter your own well. But again, it's a prerequisite there be a meter of some kind to at least quantify water consumption, even if there's not a charge to it, I guess. And then there's two pathways in the water. There's the performance path. You calculate total water reduction for both indoor and outdoor water use using the WaterSense water calculator. So WaterSense had a calculator, and they've had it for many years. Well, LEED basically said, let's use that calculator in order to determine what our performance is. There's also a prescriptive path option, which is basically pick your points, pick your fixtures, and the efficiency that you're able to get from them will determine what points you get in the water efficiency category. So reduced indoor water use, we're going to look at faucets, shower heads, and toilets. They do not have to be WaterSense, but certainly you're going to want that to be as low a gallons per minute or gallons per flush as possible. Outdoor water use, reduce landscape area that you plant, and turf is definitely something we're trying to reduce or eliminate, and then having to water that turf. So outdoor water use is definitely considered in there. And you'll notice my little asterisk there. clarifying that if you have a pool or other outdoor water feature, you have to use the performance path, not the prescriptive path. So a little clarification there. So for outdoor water use, we're talking about drip irrigation, plants that are going to be using less water, even in places that have a decent amount of rain. You can plant the vegetation that's going to use less water. That way, when you do get into drought conditions, the plants that you do have are going to be able to they're going to be able to survive better. And so again, low flow for outdoors would look something like this, depending on where you are. Now, if we want to take a second and look at water efficient products, I want to start off back in 1992 looking at the Energy Policy Act. Now, most of the time we think of the Energy Policy Act as dealing with energy, but in fact, the Energy Policy Act also dealt with water. So it set a national water efficiency standard for toilets. So toilets used to be 3.5 gallons per flush on average. But they were, according to the EPACT, started January 1 of 1994 is when it went into effect. It went down to 1.6 gallons per flush. So the toilets that you can buy today cannot have more than 1.6 gallons per flush. What about lavatory faucets? No more than 2.2 gallons per minute. So that's the most water that can come out of your typical lavatory faucet. The one I'm holding there in the picture is 0.5 gallons per minute. Very, very low flow. And the aerator is where you get most of that bang for the buck. Okay, it's the aerator that will give you most of what your water savings is, your water reduction. Then we look at shower heads. The EPACT established shower heads at no more than 2.45 gallons per minute. And I found this statistic. As of 2019, indoor water use had decreased by 22% per household, equivalent to 39 gallons per day since 1994, when EPACT went into place. So this is one of those things that has allowed us to reduce that water consumption because, again, it is a precious resource. 0.77% of all that liquid out there we get to drink. So definitely, we want to make sure that we're doing something to be very conscientious about water savings. This was a chart that was developed by a builder, a developer here in the Phoenix market, who I know well, Modus Companies. And they were doing an analysis because they needed to demonstrate for the municipality where they were building a new multifamily project. They needed to demonstrate to the municipality that they were going to be using and reducing water. So I love this because they said, Darren, what do you think of this? And I said, wow, that's a cool chart, because of course it talks about our federal standards, right, that we just went through. But it also starts talking about, well, what if we do just the water sense minimums, okay? If we look at the water sense minimum criteria, we're looking at about a 25% savings. So FYI, if you're doing water sense, you're going to be saving about 25% in those fixtures. If you went to the median option, so now we're going to push to a little bit better on our savings, we can get it up to 38%. And then what they did is they went out there and they looked at, well, what's the most efficient stuff we could get? And some of you might actually look at that and go, oh, I can do better than that. But for now, that's what they found. I tweaked a few of these numbers because I knew that they could be a little bit better. But you're looking at a 50% reduction over the federal EPACT rates is what's possible out there. You have to be careful with what you're actually getting for flows and whether or not that's going to satisfy the need or the homeowner. But this is what's possible out there. And I love this chart. And I'm not telling you what brands are getting you all of this, although I will share with you one of these items in just a moment that will get you low flow in the toilet area. So when we look at toilets, most of you are quite familiar with dual flush or single flush, right? So dual flush, you've got for your liquids, you've got the small flush, and for the solids, we got the big flush. I was working on a project where a multifamily developer needed to do something to save water, and so they said, "Well, we're going to do dual flush toilets." And so what they did is they, in order to make sure that they were in budget, they bought and put in the least expensive dual flush toilet you could put in. The problem is that what they did, and I believe this was a retrofit project, if I'm not mistaken, because they knew what their water bills were. Then they upgraded to these dual flush toilets, and their water consumption actually went up. And the reason is that the dual flush mechanism inside was cheap, get what you pay for, and it broke. And so the tenants were basically using the big flush every single time because the unit broke. Now, single flush has opportunities. Dual flush is you can get more out of it, but it's got to be quality. So this is a chart that kind of shows the evolution of what's possible out there from 3.5, the old stuff, to 1.6 gallons per flush, to 1.28 to 0.8 to 0.5. This is what's possible out there. This is coming from Niagara Conservation. They've got toilets that perform really well down at the 0.8. So that's where I stole that little statistic because I know you could get there. That's single flush. Okay. If you can get 0.8 at single flush, then forget about the opportunity to break a dual flush. Although, of course, with dual flush, they make one that's even better. Hopefully that's not breaking down on you. So again, I'm not harping on or bagging on the dual flush. Just make sure that it's a quality product. Now, this is one of the things that a toilet does to be more efficient. Okay. So now I'm really geeking out because I learned this from another guy that was geeking out as a purchasing manager for one of the large production builders, national production builders. And I'll remember he was actually on the EBA board of directors with me years ago. And I'll never forget, he and I were talking during a break and he said, yeah, we got these really low flush toilets. And he started telling me how they got them there. Well, one of the things they did was they fully glazed the piping. So if you take that piping that is in the that you're flushing and you go from a ceramic that's unglazed to glazed, you're obviously going to reduce friction. You're not going to have any water absorption into that ceramic. It's going to reduce or prevent clogging, probably reduce it anyway. It's going to increase your flush performance. So if you wanted to know how do you get to 0.8, this is one of those things that you absolutely do is use glazing. And by the way, let's take you back to the Romans. This is the aqueduct in Rome that they uncovered to reduce perhaps things getting in the water or evaporation, but they glazed it. If you look at it, they glazed it. So they had glazed the lining of this aqueduct. So again, we had these same or similar benefits all the way back in ancient times when they were doing their aqueduct. So this is just one piece. I'm not sure if all of them were done. In fact, I'm certain all of them weren't, but I thought this was a great example. Okay, so let's go back to the two saving opportunities with water heating. We talked about saving water. We talked about saving energy in the water heating process. If we do certain things like 50% of our pipe length, so we reduce the amount of a plumbing length that we have to run our water through, compact plumbing, or if we insulate our hot water lines, or we do a recirc plus R3 piping. I want to dive into this one because this is your biggest savings opportunity, hot water recirculation systems. I love these things, okay? So hot water recirculation systems. The one thing about hot water recirculation systems, even though they are awesome, is that the control system matters. Not all controls are equal. So this is back to the research work that was done by ResNet. If you were to run a recirc system 24/7, so it's constantly sending hot water out to into your pipes, so you always have hot water whenever you turn on the faucet. And by the way, all of these options right here are going to prevent you from wasting water. Their objective of all of these methodologies is to get hot water there, so when you turn on the spigot, you have hot water. So all of these are going to equally more or less save water, but they're not all going to equally save energy. So if you have no timer and you're constantly sending water out and bringing it back and heating it, you're talking about a 65 to 70% hit to your energy. So you don't want to do that. Of course, the base case here is doing nothing. Next, what if we have a temperature sensor? When the water hits a certain temperature at the furthest faucet usually, then it will turn the pump on and it will run it, okay? And then we've got demand or occupancy sensor. You walk into the bathroom, and by the way, the temperature sensor, you're still not saving there. But if you go to the demand occupancy sensor, well, we're not going to run the pump unless we go into the bathroom. Well, what if you went into the bathroom just to get a tissue? you didn't go in to wash your hands and take a shower and you needed hot water. Well, you ran when you didn't need to. So you're getting savings because you're only running the pump when there's demand, but you're doing it more than you should. The manual sensor, okay, that is the premier way to go, where you say, I need hot water, and you push a button and it brings hot water to you. Now, you might say, but I have to wait. Well, you have to wait now, except now you're wasting water and you're waiting. But what we're doing with the demand is we're going to wait the same amount of time, typically. And so that water will be delivered. You go off and do whatever you would have normally done while the water's running. When you come back, the pump will turn itself off when it hits temperature. And now you turn it on, you got hot water. So this is the very best way to accomplish this. In new construction, we're usually going to run a return line back for new construction. And in new construction, the code requires that that hot water return line be insulated to R3. Now, in a retrofit or in new homes, we can also put basically a crossover and use the cold water line to bring the water back. So that's what we would do in a retrofit is we could put a pump at the furthest fixture and then we could run it that way. Or we just put a sensor at the furthest fixture, but ultimately we're using the cold water line to bring the water back. Now, the automatic shutoff options, if we have a 24-hour timer on there, so if we run a timer that allows that water to run maybe a couple hours, the pump will run a couple hours in the morning and the evening. That's one way to do it. Not a fan of that because we don't have demand, okay? It's running it when we don't need it. So we don't necessarily want to do this, but I know this is a very popular option. On when the water temperature drops, again, not a great option because we're not calling for water and it dropped in temperature, but don't send more water out there. We already showed you that's a big energy drain. So we don't want to do that. The occupancy sensor, you walk into the bathroom and it senses you there, turns the pump on, mixed, you get some savings there, but it's not optimum. But the manual push button, that's the way to go. So now if we look at the IECC, the International Energy Conservation Code, they have a hot water recirculation and temperature maintenance system criteria. And I want to point out that this is something that I think a lot of people miss. And I know the builders miss it. I know a lot of code officials miss it. Controls for circulating hot water system pumps shall automatically turn the pump off when the water in the circulation loop is at the desired temperature. Okay, so the system that you install in order to meet code must turn off when it hits the right temperature and when there's no demand. Okay, this effectively takes out the timer because the timer will turn that circulation pump on when there's no demand. Okay, not good. That's not what we want to see happening there. Okay, that is not what we want to see happening. And then also on here, what we have, sorry, we got pop-ups coming up on me here. We also have no auto on off when temperature drops too low because that doesn't work, right? We're getting demand because the temperature called for the pump to turn on, not because of a demand. Now, if we look at the demand recirculation system requirements, 4035111, we ultimately are getting the code saying, hey, demand is what we want, something that will deal with that. Manual occupancy sensor, that's what meets the code. There's a lot of builders installing timers on hot water recirculation systems, and the answer I got when I called them on it is, hey, look, the homeowners, they want water, when they turn the spigot on, they want water then. And it's a homeowner satisfaction thing. So if they pay extra typically for this upgrade, they're going to want that water now. We've got to educate the homeowners that that's not a good way to save water, and it's a good way to save water. It's not a good way to save energy, and it's actually a penalty to them. And it doesn't meet the code. So keep that in mind. All right, let's talk about rainwater harvesting here. Rainwater harvesting. Okay, let me see here. All right. So if we look at rainwater harvesting, we can either do the 55-gallon drums that we, plumb ourselves and run to a storage somewhere and run out to the irrigation, turn it on. So this is the homemade method. This works, okay? But then there's also something that is, factory made that's, a little bit more manufactured, a little more sophisticated. But rainwater capture, again, it's the simplest, oldest method of self-supply of water. Capture stuff that's coming from the sky, okay? This water is typically not going to be used for drinking, but we can use it for landscaping, watering the livestock or animals, domestic use if it's properly treated, like for flushing toilets. And one of the challenges is harvesting enough in order to meet your demand. So if you were to go to the Texas AgriLife extension, there's the URL at the bottom there. You can drop in exactly what your system looks like, your catchment system, and it's cool because it will basically tell you where you're getting extra and where you're not getting enough water. So if you populate this thing for where you're located, it will tell you where you're going to have to supplement water. And I don't remember where this location was. I used to know when I first put this together, but I can't remember now. And I don't think it says, but in this particular location, we're talking about, we're definitely doing great during May and June, but the rest of the year we're needing to supplement. So really rainwater harvesting comes down to, how much are you really benefiting from that? And of course, where it rains more, it's going to be better as opposed to here in Phoenix. Some people do it, but it just doesn't make a ton of sense for us most of the year. But again, to each their own. Let's look at gray water systems. So for gray water, what we're doing is we're capturing water that is pretty much just for washing, right? Your bathtubs, your showers, your sinks, not your kitchen sink, your bathroom sinks, your lavatories, clothes washers as well. That water is going to go into a surge tank. The surge tank, then you pump that, and it's going to go into your out to irrigate usually your lawn. Now, the gray water typically accounts for 50 to 80% of your water waste stream. So that's a real opportunity, gray water is. Reuse the water for landscape, best for trees or ornamentals. In other words, run it right into the ground. Drip irrigation, soaking turf, those are all good things, but it's not recommended that it be used for a sprinkler system. You do not want to aerosolize by blowing it into the air, that water that's going to have some bacteria in it that the plants don't mind, but certainly you don't want that blown into put into the air that might ultimately be something that somebody will ingest either through breathing it in or whatever. So it's not recommended for a sprinkler system. Another thing that this chart doesn't include is if we were to use the condensate coming out of the air handler, right? Some parts of the country, this thing runs really, really good stream of water in the middle of the summertime, if you're in a humid climate especially. And so you can run this out. And in fact, I just had a question that was asked to me the other day about this. So I did some research on where this would be acceptable, and it is acceptable. You do have to get approval from your local code official. That's the only thing, is they have to approve it, but it's not disallowed, okay? But you can definitely use the condensate, and you can run that out to a drip or in this case, it was a rainbird screen that you could drop it into, and it would water the roots. Now, you do need to make sure that you're following the code. So the IRC has two sections, the on-site non-potable water reuse systems. And then also, if you look at the International Water Conservation Code, they also in Chapter 11 have their information on the gray water system. So depending on what code is cited or you have to follow, make sure that you're following these guidelines and requirements for your non-potable water, both rainwater and gray water. Keep that in mind. So this was an interesting thing from Grider, one of the manufacturers out there that was getting in on the gray water. You're basically putting a little water treatment facility right in your home. And by the way, I have to give credit to Green Builder Media, because this is how I found out about this. Green Builder Media did an article on it. Mike, that might have even been an article you wrote, by the way. Maybe it was you, maybe it was somebody else. But 25% of a family of 4, and we're basically taking just the shower water, running it back into our toilets for flushing. Okay, I want to talk about 2 other topics, and then we'll wrap up, okay? Just about at my time here. So leak detection is not something that is typically thought of in the water savings or water efficiency products, but leak detection is a big deal. The average U.S. home wastes 9,400 gallons of water each year just in leaks. Okay, just in leaks, 9,400 gallons is the typical U.S. home, or the average. Property damage from water leaks is 7 to 10 times more likely than fire or burglary. Okay, fire or burglary. More than 2.5 million homeowners experience water damage every year, okay, from water leaks. And then leaks cost $13 billion in damage in the U.S. annually. So leak detection is not an insignificant issue. Okay. It's not an insignificant issue. At this point in my regular water class, the full class I teach, I usually will ask everybody, have you ever had a water leak? Okay. We'll poll them. We'll say, have you ever had a water leak? And I'll poll and I'll get a statistic on the percentage. 75% is my running average. Anywhere from 70 to 75% of the people that I've had in my classes, that is the percentage of people that have had, in their personal experience, a water leak, water damage type of a situation. So yeah, this is happening all the time. This is a very popular thing. So what do? We've got to, first of all, detect the leak and then manage that leak. Point leak sensors are by far the best way to do this, okay? This is a remote sensor, like the water bug you see up there in the right-hand corner. It's a little sensor that you put in your bathroom, usually by the toilet, in your laundry room, in your kitchen. You hide these things. It's a hard wire. They can be remote, but you've got to change the battery out on them regularly. But they do make them that way. But hardwire it back to the central brain on this thing. And what it does is you can see the little dimples on there. And if water closes the loop, so if you get water hits one little foot and it hits the other one, it closes the loop, sends a signal back to the shutoff valve, shuts that water off. And I'll tell you that I had a water leak in my house. I was Saturday morning, I was laying in bed, just doing some stuff on my phone. And it was probably about 8 o'clock, 8:30 or 9. And all of a sudden I hear this. I run around the corner into my master bathroom, and the water line on the bottom of the faucet had fallen off, and it was overshooting water against the ceiling in my bathroom. I was in there probably within about 15 seconds. And I got in there within 15 seconds. I shut that thing off and my bathroom was flooded. Okay. And I have nightmares every now and then thinking about that situation. What if I wasn't there? That intense amount of water would have been flowing. So I'm back to the kind of the bad news situation. But this is how you solve that problem with that sensor, because it will turn that water off. Turn it off as soon as it senses a leak. You do have other options, like an all-in-one device, because they're also measuring the temperature of your water. So as your water if you're in a place where it freezes, that's not Phoenix, but if you're in a place where it gets freezing out night in the wintertime, you're going to want to know if that water in that line is going to get too cold. So if it gets too cold and it starts to approach freezing, it will shut the valve off. But it's also measuring flow. So the last option, which is not awesome, because this is a flow monitor, and if it senses that you have out of normal elevated flow or flow that's too long, it will send you a signal. It does not turn the water off. The last version will turn the water off when there's a signal, but this one will just tell you that there's a problem, and then you have to go manually turn it off. But these are all good options. And in fact, the lowest option, I know for a fact that Farmers and Amica and other insurance companies, they will give you a discount on your homeowner's policy if you have at least a flow monitoring system, like you see, like the one that I'm showing you here. So there is an opportunity to get a discount on your homeowner's policy, and the insurance companies are actually promoting this because it's going to save them a lot. If they can even give these things to homeowners to install, it would save them a lot on the back end for claims. Okay, the last thing I want to talk about is water softeners, okay, and specifically non-salt. The benefits of a water softener is reducing that lime scale buildup. Go back to the ancient Romans, right? We don't want that calcium buildup, and it happens in our plumbing today with our hard water. And so we will reduce those hard water deposits, but we're also going to have, more moist skin, shinier hair, less chlorine in our shower stream, that kind of a thing. So definitely benefits, but there are some cons. It wastes approximately 150 gallons of water each week in backwashing. So your soft water system has to backwash, okay? Has to backwash. 7,800 gallons each year effectively is what we're talking about. Salt flushed into the sewer will pollute the source, the place where that sewer is ending up in your rivers, lakes, or in your wastewater treatment plant, increasing the operating costs of sewage treatment facilities. In Phoenix, the city of Scottsdale, they actually give you a rebate if you get rid of your water softener and go to a non-salt system or just get rid of it. They'll give you a rebate to do that because they figure it costs them more to extract the salt out of the water because the city of Scottsdale reclaims 100% of the water that comes out of the sewage system. So everything that goes into the sewer system, Scottsdale reclaims, and it drives their cost up. So they rebate putting in either getting rid of your softener or putting in a non-salt system. So you've got costs as well, right? You've got the cost of the water that you have to replace because you're running it to backwash. You've got the cost of the electricity. You've got the cost of your bags of salt or potassium if you go that way. And then you've also got regular maintenance. So there's costs associated with that. The non-salt systems, here's just a couple of them that are out there. You've got, first of all, no salt, no electricity, no wasted water. The only maintenance is changing out the cartridges. So this is something that you need to at least give some thought to. This does not remove the hardness. What it does is it dissolves, as I say there, the hardness minerals in the water. They bind to the chemical, the one flow media in the lowercase there. They bind and then they wash out in the water system, or they come out in the water as harmless. Okay, so this is one of the things that we should consider in order to save energy and to save water, a non-salt water softener system. So we've covered a lot. I think, Mike, I was pretty close to my time of 60 minutes. We wanted to set the stage by looking at this idea that water and the history of water savings and just the need for water, that really is an ancient issue. And we do have scarcity. We talked about the Nexus. We talked about the energy water efficiency programs that are popular out there. We talked about some of the products, not all of them. I know there's a lot. We just talked about the primary ones. And then I wanted to make sure that we did address rainwater, gray water, and then throw in two items that are not typically thought of, being the non-water, non-salt softeners and the leak detection systems, things that are not often thought of when it comes to water. So I want to take a second just to remind everybody or let everybody know that I do have other classes that I make available at Learning Edge. I usually do a series of 6 classes. This is my 6th series class. What goes along with that, if you complete them, is master certification, high performance home master certification. That next session I'm teaching starts at the end in 2 weeks, in April 22nd. I have a number of other classes that are available if you go to my website. Would love to have you in any of those classes. Water efficiency and the Water Energy Nexus is just one of those classes that I make available and teach. So would love to include you in any of those classes. And I want to get some feedback for you before we jump into Q&A. So if you'll get out your cell phones and you'll point at the QR code, Mary, if you could drop that into chat as well, the link, people can use the chat as well. This is the feedback survey. There's 3 questions in there. It's simple. Give me a grade. You got to do that. How'd I do today? Give me a 1 through 10. But if you guys would have something positive to share that I can share with other people, of course, I would love that. But also, can I do something different or better? Provide some constructive feedback. That's always welcome as well. When you're done with the feedback survey, you then will get an email to download the slides that I shared with you today. Those will all be available to you if you complete the feedback survey. Mike, now we're into Q&A, and I want to let you do that. And in fact, I think Mary will keep the slides as are. Mary, are we okay to leave things as they are? Or do you want to switch the presenter? Mike, what do you want to do, Mary?
Let's just keep going as we're going. We're doing fine.
Perfect. All right, Mike, I'm ready for anything you got, I think.
Yep.
Go for it.
Just as a note to everybody, the link will be provided in a follow-up email that you'll receive tomorrow. So that link that you were asking about, Darren, that will be.
No, the link that Mary's going to drop in is for the feedback survey.
It was in the chat before we restarted, so it's gone.
Oh, okay.
Unless you want to put it in, or you can send it to me right now, I can put it out. But I don't.
Okay,
I'll get it from you.
All right, I'm going to back up to the QR code then. That way people have that available to them. All right, there it is. Okay, so shoot that with your phone and you guys can do that. Okay. All right, Mike.
All right. So yes, if anyone has any questions, please send those in. I mean, gosh, I could talk for hours on this topic, Darren. And I think the thing for me is, what are you seeing? Because you're out there in Arizona, okay, which obviously has its own challenges. You talked about some of those challenges during this session. What are some of the most innovative things that you have seen on various projects?
I'll just tell you, the most of what I'm looking at is what's happening in the production world. The water bugs and those types of technologies. I mostly see that in custom homes, Mike, for leak detection. Although leak detection is becoming more and more popular even in the production builder environment. But most of the time, what I'm seeing is not very innovative. It's basically putting in low flow fixtures, and to some extent, the local utility company that I work with that does electricity, Salt River Project. Salt River Project is also a water provider, so they provide some incentives if you put in some low flow fixtures and low flow items. They'll provide some incentives around that. And so I'm not seeing a ton of innovation other than putting in the low flow fixtures and the low flow toilets occasionally is what we're seeing, because there's just not a mandate where we are to do that. So, Mike, I might be a bad example because we don't have that. You go to California, of course, and there's a whole lot going on in California for water efficiency. We have less of that going on in Phoenix because we're doing a lot of things in a lot of other ways. And so probably not a great answer for you, but and probably a sorry answer for you because I can't say that we're doing a ton of stuff, but that's kind of our reality.
One question I always ask whenever this water topic comes up and we're talking about alternative water, which is what you were hitting on near the end. And now, especially because you're located where you are, do you foresee a day where alternative water systems become required? Some sort of alternative water system becomes required on new builds.
When you say a system, as in just water saving fixtures and water saving things like that, is that what you mean?
No, I'm referring more to like rainwater or gray water system being required.
I don't see gray water or rainwater being definitely not rainwater. I don't see that being one because we just don't have enough of it to make dollar and cents cost benefit. Gray water maybe, but I think that's not going to be something that I see as a requirement. And let me tell you why, is because Mike, we have our local municipalities, they do a ton with water reclamation after it hits the sewer. So there in my regular water class, the full length one, not the one today that's a little more short. I actually have a whole section where I talk about water reclamation examples throughout the Phoenix metro area. And we have lots of municipalities that are doing wastewater treatment. Lots of doing wastewater treatment. And it's not just here. I know it's done elsewhere in the country, but it's a big deal here. So there's a lot of reclaimed water that is being used for watering for the irrigation systems and whatnot. City of Scottsdale even has a water treatment facility that treats water all the way back to more pure than bottled water. That's how good that facility is. But that's almost a novelty that they do that. And it is available. So I don't see gray water being anything that we do because the municipalities are doing such a good job of reclaiming the water and treating it and then sending it back to those non-potable uses. What I do see though is I think there could be in the future this requirement that we're using more efficient fixtures. That's a simple one. Change it out for a low flow shower head, a low flow faucet, low flow toilets. And I'll even go so far as to say that I think the shower heads probably not going to get messed with because the homeowner experience is biggest when you're taking a shower. Now, I'll just tell you, I am perfectly fine with my low flow shower head. But again, I'm a geek, and for me, that's just me. But a lot of homeowners, they want to make sure they got enough water, especially women getting the shampoo and stuff out of their hair. If you've got a lot of hair, you got to have some water pressure, and the low flow is what I usually hear for a complaint there. But for toilets and faucets being low flow, that's something I could foresee being a requirement down the road. And Mike, I'll even say that we're going to continue to grow Phoenix metro area. We're already one of the largest and fastest growing metro areas in the country. And as we continue to grow, our demand for water is just going to continue to grow. So we can attack that with efficiency. But I also think down the road, we're going to start to see restrictions that you might have seen elsewhere. I know that a lot of people don't want to hear that, but I think it's inevitable down the road that we are going to see restrictions as we continue to increase demand with increased population.
Yeah, and Vegas is another good example of a municipality that really reuses their water as much as they can. Obviously, they're going to have some evaporation loss there. The other thing I was going to mention real quickly, and I'll put a final call out for questions, is I think one thing that's going to become more pervasive throughout the construction industry, and especially on the multifamily side, is the water demand calculator and the usage of the water demand calculator that's offered free of charge through IAPMO, because there's some significant dollar savings when you can size the pipe to a more appropriate size for the property type. And so I guess that would be my verbal feedback to you, Darren, would be if you are able to add a little bit about that to your presentation, because that is something I think is going to catch a lot of builders' attention when you start to talk about the dollar savings.
Mike, thank you so much for that. I actually removed that for today's presentation because I would have gone on for another 5 minutes. So, Mike, you were in my class. So you were my full class, you were there. And I do absolutely have the IAPMO and the Hunter curve. The Hunter curve's been around for, 90 plus years. And that's way plumbing systems have been sized forever. But the Hunter curve, going back to the 1930s, it basically assumes a water flow and piping that we don't have anymore. When we have low flow fixtures, we don't have the sizing of the pipe anymore. And so you're right. The IAPMO folks, they created the app that's totally free, Mike. And I have that. I put the URL in my presentation for that. You guys can just look it up, IAPMO water calculator. It's a free tool. And you put in what your water flows are, and it will tell you what the sizing for your system should be, your plumbing system, because you can get away with less pipe, smaller pipe. So then you're to that point you raised, Mike, of, hey, my construction costs are going to go down because I've got less piping. I need smaller pipes, less piping. And so, yes, there's that opportunity there. And I appreciate you bringing it up, Mike, because I do think that's important. I just didn't have time to bring it into today's presentation.
Yeah, no, I remember that from the longer course now that you mentioned it. And going back to the flow rates and some of the low flow stuff, I know that there are certainly some places who already have requirements for water sense fixtures. And those rates are built into requirements. State of Colorado is one that easily comes to mind for me, but there are other places as well. So we're seeing that. Hopefully, we see a little bit more adoption of that, because as places grow, especially, you put the drought monitor map up early in the presentation. As we see growth in areas where you're typically seeing orange, yellow, and red on the drought monitor, we've got to figure out, hey, what are we going to do here? So,
absolutely, 100%. And Mike, I really appreciate all of your passion and the work you do on water, and the things that I know you do the water conference. Don't you have a water conference that you do for once a year, right? And so that's awesome. There's a lot of people that are diving into this topic. And I think, Mike, it's kind of the ugly stepchild. We focus a lot of time on energy, right? But not on water, which is why I love to teach my water class, because I get a chance to dive into this other place. I mean, as a kid grow up in Phoenix, I could not walk by a spigot that was leaking and not go over and turn that off. And if I couldn't turn it off, I'd turn it as hard as I could to try and turn off that spigot, because I find it very hard to waste water. And it was just, part of what we do. So anyway, I do appreciate all those out there that are focusing on raising awareness for water efficiency.
Yeah. The event that Darren was alluding to there is the Next Generation Water Summit. I've been putting that on. This will be our 8th year. So you can check out information about that at nextgenerationwatersummit.com. It's coming up in 2 months.
In 2 months?
Yeah. It's a hybrid event, so you can attend remotely or you can join us in Santa Fe, New Mexico. So, we talk about a lot of nerdy water efficiency stuff. So I want to take this moment now just to say thank you, Darren, for talking about this topic today. Obviously, it means a lot to me, and I'm appreciative of all the people who attended today. And if you missed any part of this at all, you can either scan the QR code, go to the link in the chat, go to the link that's going to be in the email that you'll get tomorrow. You can fill out the feedback survey. You can get the slides. You can watch this recording on Green Builder Media's YouTube channel. Many ways to get this information and to share it with all your closest friends and neighbors and colleagues and acquaintances. Thank you also to PowerShift by NV Energy for their generous sponsorship. We very much do appreciate them being a longtime partner of Green Builder Media. So check out PowerShift by NV Energy. All right, hey, our next event is the big one. It's the Green Builder Media Annual Sustainability Symposium, and it's going to start 3 weeks from today. Yep, join us for this wonderful two-day event. It runs Wednesday, April 30th, and Thursday, May 1st. It's going to run from noon to 3 Eastern each of those days. For more information and to register, please go to greenbuildermedia.com, and you'll easily find the image for the symposium on there. Thanks again for joining us today, and hope to see you in 3 weeks. I will have the honor of emceeing that event. Until then, stay safe, stay healthy, and take care, everyone. So long.